By combining cloud billing data with telemetry from the Datadog agent, we're able to allocate costs within dynamic, multi-tenant, containerized environments, where ephemeral workloads and shared infrastructure typically make cost attribution difficult or inaccurate. Here you can see the total Kubernetes spend for AWS, Azure, or GCP, broken down into workload usage, workload idle, and cluster idle costs. For example, we can quickly identify that $250K is being spent on workload idle resources, highlighting an opportunity to right-size workloads. As we drill down further, we can view costs per cluster, per namespace, at the workload level such as deployment or replica set, or even drill down to the individual pod. Here you can see costs allocated to CPU, memory, GPU, storage, and data transfer for the default namespace. Drilling into compute, your team can examine CPU requests versus CPU usage with direct access to the underlying observability data used for the allocation. This level of allocation makes it easy to identify inefficiencies. With highly granular Kubernetes cost allocation, FinOps teams can promote cost accountability while giving engineering teams the insights they need to optimize resource usage across even the most complex Kubernetes environments. Next, let's walk through our custom allocation rules feature, available for AWS, Azure, and GCP. This capability enables precise showback and chargeback by letting you define rules to split and reallocate costs associated with shared resources, untagged resources, or untaggable line items. You can choose from several allocation methods, including an even split, custom percentages, proportional allocation based on cloud spend, and dynamic allocation using observability data such as Datadog metrics. In this example, we're allocating the costs of a shared user authentication service dynamically by metric. We're using Datadog request metrics to dynamically distribute the service's costs back to all consuming services based on daily usage of the user auth service. Additionally, we've applied a partition based on the environment tag. This ensures that 1, costs are first split by environment, for example, dev versus production, based on the total usage within each. And then 2, within each environment partition, costs are then allocated proportionally to the individual services based on their relative usage. This two-pronged approach provides a more accurate and equitable distribution of shared costs, especially in complex multi-environment architectures. Now, let's take a look at tag pipelines. With tag pipelines, you can fix missing or incorrect tags on your cloud bill, or create new inferred tags that align more closely with business logic. For example, you can add a department tag based on an existing service tag associated with the department. You can also do this at scale using reference tables that automatically sync with S3, allowing you to dynamically map business hierarchies, such as cost centers or teams, onto your cloud cost data. You can also alias tag keys to clean up tags, such as in this example, where there were multiple environment tag keys being used. Finally, let's take a look at the Tag Explorer, which provides visibility into the full lineage of tagging across all of the cost data sources in your environment. In addition to pulling tags from the underlying billing datasets, we augment this with tags from the Datadog agent, software catalog, and Kubernetes environments. We also generate out-of-the-box tags to unify observability and cost data in one place. This holistic approach to cost allocation helps ensure that your cost reporting is both business aligned and operationally accurate, making Datadog a clear leader in the cost allocation space.